So my dear student, welcome to the another video on the penalty approach method. This is another important problems by using penalty approach we solved, right? So here is a question. For the bar as shown in the figure, you have to find the displacement fields, stresses, supportive reaction. It means unknown displacement you have to calculate as well as the stresses and also support reactions using the penalty approach. This is very important because we are solving using penalty approach. Right, so using the elimination method that is already solved, you can check out in the playlist, right? So only using the penalty approach problem I am going to solve now, right? So this is a given diagram in the question, and right side the values are given. Like these are the two element problems, and load is applied at the middle of the bar element, and the length is total 300, so it is divided into 150. Load is applied here. The value is 16 to 10 power of 3 Newton, and area for the element 1 and 2 is same because it is uniform, and Young's modulus is also same because it is a having made with the same material. Only the important thing in this problem to understand is the value. There is a gap here from node, from the end of the bar to the fixed end, there is a gap here. So this gap we used to say this is a displacement is given. It means it is the displacement of either u3 or q3, okay, whatever your notation is there, anything you can imagine. So this is an displacement value is given, remember, okay? So let us say this is q3 value is 1.2 millimeter. It means the displacement at node 3 is known to us, okay? So similarly we will follow the same procedure as we have done in many of the problems, like k1 k2 you have to find out for the stiffness matrix. Okay, this is for the element 1, this is for the element 2. I no need to explain again more here because which is already done in many of the problems. If you don't know, just go to the my starting problems so that you will understand everything. So k1 is equal to what? For the bar element it is k is equal to a by l. Equation is in the matrix 1 minus 1 minus 1. So this is an basic formula where we are substituting here a1 e1 l1. Okay, same thing you have been done, and this is equation. Finally we got this is an equation number 1. Okay, this is an equation number 2 because here the values will be changed as this is a2 e2 by l2. Okay, same equation, you got this value. Now you have to make the global stiffness matrix. Global stiffness matrix is nothing but adding k1 plus k2 is equal to what? K. So k you have to find out. So you can find out 10 power of 6 outside the matrix we have taken here. So here the displacement you can write 1 2 3 1 2 3. So one row, first column, first row. So first column first row is 0.03, that is taken here. First row second column is minus 0.03, that is taken here. Third row 1 3, there is no relation between 1 and 3, so you can take 0. Similarly you have to write down for 2 1 2 2 2 3. Similarly 3 1 3 2 3 3, you have to check from here. And if you don't know about how to make the global stiffness statistic, again you can check it out in the playlist, or I will provide the link in the description. Separate video I made only on the global stiffness matrix, you can just go through it. Okay, after that we have to write the global load vector. So anyhow we got k, because you have to make the equation in this format, k u is equal to f. Just now you calculated k, now you have to write down u, next f. Okay, so first let us write the equation for f. F is equal to what? It is the equation for f1 f2 f3. Okay, forces at 1 2 3. So as we can check in the diagram, the force is applied at the middle of the bar, so you know only f2, there is no f1 and f3, so it will be taken as 0 0. Okay, so finally you obtain this equation: 0 force at 2, that is 16 to 10 power of 3 into 0. Okay, this is a force vector. Now you have to write the equation for q or u. Okay, anything you can be make the right. So k value is what? This one. K is the global stiffness matrix we have calculated already, and u as u or q, u is equal to what? It is u1 u2 u3, or here q taken as, it means better we will go with the q1 so that it will be more understanding instead of u. Okay, so u1 is equal to q is equal to q1, q2, q3. This is a displacement vector. Okay, but here at node 1 q1 is 0, taken as 0. Okay, but you cannot take 0 in the penalty approach directly, right? This is very important to understand here, because in the penalty approach you cannot take the displacement as 0 because of fixed. Okay, in elimination method we will take where q1 is 0 because it is fixed, but in a penalty approach you cannot directly take as 0 here. This is a, you have to remember. Okay, you cannot take 0 here. So there is a known values at q1, and also there is a known value at q3. Okay, and also q2. So all the values it will be known to us, cannot write 0 directly, right? So these are boundary conditions values. What are the boundary conditions value? You know force, okay, and you know the q3 value. Q3 value is known. Okay, that is already given in the question, 1.2 millimeter. So remaining q1 and q2 you have to find out. So here the value of c is taken. What is this? Max Kij is equal to c. C is equal to 0.06 into 10 power of 4 into 10 power of 6. So what is this? You have to understand very clearly now. This is very important in the penalty approach method. Okay, so till now the same procedure you have followed in all the problems, then no doubts, but from here you have to understand this. Okay, so there is a c value will be taken in the penalty approach. C is nothing but it is the value of maximum Kij into 10 power of 4. Okay, so what is this Kij? Kij means in this matrix, in the global stiffness matrix, you have to find any maximum values. Okay, now it is in 3 into 3 matrix. In this, which is the maximum or highest value. Okay, Kij is nothing but it can be any row, any columns. Okay, so maximum values you can check 0.06. Okay, 0.06 is the highest value. So this highest value you can generally find out only in the diagonal. Okay, that is also only in the diagonal you will get. And okay, so maximum values is 0.06 into 10 power of 4, and again outside there is a 10 power of 6. So this is also having the relation 10 power of 6 into 0.06 into 10 power of 4. So first we will write 0.6, again we will write 10 power of 4. So finally how much you got? This one, 0.06 into 10 power of 10. 6 plus 4 you have to make, then you will get 10 power of 10, right? So after this, after finding the value of c, now this c value, okay, so this c value will be added in the fixed supports. Where are the fixed supports? Okay, it will be added in the global stiffness matrix, as well as it will be added with the forces, okay, where the nodes are fixed. So we can check that the c is value added in, okay, you can just check here, this c is added here and another it is added to this column. It means the first row, first column, it means at displacement 1, okay, here it will be added, and also at q3. So q3 should be added, whatever the value you got, 0.0 plus c, okay, plus c is added here with the existing value. Again at the force also 0 plus c into a, 0 plus c into a is nothing but that same unknown value, as you can say q1 or q2, okay, and here also at force 3, 0 plus c into a is added. Now in the next steps, after adding, just some calculation part will be there, you have to do it, and you have to follow any methodology to make this equation. Okay, just you can add these to this one, later it will be taken as common, okay, just to make the shorter values. Okay, so any method you can just do it. adding and taking the common outside, again inside method this will, after that you have to make the matrix multiplication. Okay, so as I told you here, 0 plus c into a. Okay, displacement qa is nothing but j. So finally you got q is taken as 0 because it's fixed support, so there you have to add force as 0. Okay, again here force directly which is given in the question. For the row 3, it means F3 0 plus C into Q2. So C into Q2 value is given, that is 1.2 millimeter, that has been made the multiplication with this. Okay, C into 1.2. So finally got this 0 60 into 10 power of 3. Okay, so how much it is? 7.0, that value you will get here. Okay, you can just make this calculation and whatever you got just substitute here, and this is the final output here, outside value matrix, and this is inside the matrix. Now you make the matrix multiplication. Okay, just do the matrix multiplication like 6.01, okay, into q1 minus 1 q2 0 q3 is equal to 0, and divided by 0 divided by this value you will get 0, and again totally you have to make the second equation, third equation. Okay, just basic, by solving that you will get the value of q1 q2 q3. Okay, so anyhow q3 is known to us, that is 1.2 millimeter, and this is q1 value as 7.5 into 10 power of minus 5. As you can, this is very it's not 0 but it is almost is equal to 0. Okay, very near value to the 0, that you can say. And q2 value you got 1.2 millimeter. Okay, this is a unknown displacement. So now the same thing you have to write in the equation format, q1 q2 q3, like we have written like this, right? q1 q2 q3, same thing, whatever you got how to write in this format. Again the stresses equation, sigma is equal to eb into q. Okay, stress you can calculate sigma 1 sigma 2, and also the reaction forces. Okay, this is the equation to calculate the reaction force in the penalty approach. R is equal to minus C q1 minus a1. Okay, and here R3 minus C q3 minus a3 is equal to this value. So the values you will be obtained this. Okay, so this way you have to do, or you have to solve the problems using the penalty approach, and this is very important problems. Okay, please do support and thank you.